All right, when you're talking about end behavior of polynomial functions, what you're really trying to figure out is what happens to f of x or y as x gets really, really big or really, really small. So if you take a look at some function, x to the third, you can think about as x approaches infinity, or if it gets really, really big, think about x equaling a million. If I take a million and cube it, I'm going to get some other really, really big number, but it's going to be a positive number. So f of x, or the function, will also approach positive infinity. But if I pick some really, really small number like negative a million, so as x approaches negative infinity, well, if I plug negative a million into something that's raised to the third power, it's also going to be negative. So the function is going to be negative. And you can see that this is going to be true for all functions that have an odd power and a value is positive. So I could say the same thing for f of x equals x to the fifth. It would be the same end behavior. Or x to the 21st, or any odd power would have this same end behavior, as long as the a value was also positive. So when you're looking at a function, for instance, x to the third plus 2x squared minus 6x plus 3, the only thing you really care about is the exponent on the leading term, so the 3, and the leading coefficient. Is it positive or negative? Other than that, you can ignore the rest of the function. All right, so let's take a look at this function, f of x equals x to the third. You can see this is an odd function because the two ends of the graph are opposite. You know it's an x to the third because it has two terms. But remember, whatever end behavior we come up with, it's going to be true for any function that is odd and has an a that is positive. So as x approaches infinity, if you look at the right side of the graph, what is the end of the graph doing, or what are your y's doing? They're increasing, so they're approaching positive infinity. And as x approaches negative infinity, so if you're looking at the left side of your graph, what are your y's doing? Well, they are decreasing, so f of x is approaching negative infinity. Notice that I used f of x in the equation, so I used f of x in my end behavior. If we have a negative now, so now we have a is negative but n is odd. As x approaches infinity, so if you look at the right side of your graph, what is the end of your graph doing, or what are your y's doing? You see they are decreasing, so your y's are going to negative infinity. If you looked at the left side of your graph, or where x is approaching negative infinity, what is the end of your graph doing? F of x is approaching infinity. Now let's take a look at an even function. You know this is going to be an even function because both of the arms of the graph are going up. So you know that it will be something like y equals x to the fourth, or y equals x to the sixth, or y equals x to the eighth. You know this one happens to be x to the fourth because it has 3 terms. And remember, the exponent is always one more than the number of terms. But it is going to be true for any function that has an a that's positive and n is even. As x approaches infinity, so as I'm on the right side of my graph, y will approach infinity. Notice that if I use y in my equation, I should use y in my end behavior. And if I use f of x in my equation, then I should use f of x in my end behavior. As x approaches negative infinity, so if I'm looking at the left side of my graph, y is still increasing. And on the last one, for instance, y equals negative x to the fourth, as long as a is negative and n is even, the end behavior will be as x approaches infinity, y will approach negative infinity, and as x approaches negative infinity, y will also approach negative infinity. If you have any questions, let me know.